Today we're building one of the fastest and most compact rendering systems that is possible today, thanks to the Ryzen 3950X, the RTX 3090, and of course the Ncase M1. If you're a product designer, an architect, an engineer, or do any 3D work for your job, you'll want to pay close attention to this one. Not only does this system absolutely chew through renders, but it's also very quiet and very compact. Now this is a very straightforward build. Many of you will be very familiar with the parts that have gone into this, especially the case if you're subscribed to the channel. But there are a few things that you should definitely know before building, specifically when it comes to the case and the graphics card. So let's take a look at all of the parts, put this thing together, and then see how it performs. So we're going with the RTX 3090 here as an all-out, no compromise GPU option. The 3080 is also an excellent choice if you don't have as large of a budget, don't mind 15% longer render times, and also don't need more than 10 GB of video memory. This is an expensive GPU, so if 3D work is more of a hobby than your actual job or aspiration, the 3080 makes a lot more sense. I'm also aware that the RTX 3090 lacks the proper workstation driver support, which means that performance in some engineering and simulation apps won't be exactly what you'd get from a proper Titan series workstation card. Still though, with 24 GB of video memory with a peak bandwidth over 900 GB per second, there are still plenty of creative professionals which can significantly speed up their workflow with this GPU. Now the specific card that we're going with here is important because a lot of 3090 cards on the market just won't fit in our ITX case here, the Ncase M1. So I've gone with the ASUS Tough model here, which satisfyingly reaches the limit of what you can put in this case, but also do consider the XC3 from EVGA if you want something a little bit smaller or maybe pending on availability. The ASUS Tough is a 2.5 slot triple fan design, and I'm expecting some really good thermal and noise performance here, as their 3080 was seriously impressive. So this machine is focused more on GPU rendering horsepower than CPU, but it's really up to you and what apps you use to decide how many CPU cores you actually need. If you do have the budget, a 16-core 3950X would be the best choice. There you've got excellent single-threaded performance, and you'll have enough rendering power here to back up your GPU in apps that don't support GPU rendering. If you don't need this many cores though, and GPU rendering is all that you'll be doing, I'd at least get an 8-core Ryzen 3700X at minimum. But one non-negotiable part here is the power supply, and you really need at least 700 watts here to kind of be on the safe side. I'd recommend Corsair's SF750. It's a 750 watt SFX power supply with an 80+ platinum efficiency, and believe it or not, this will actually handle both the 3950X and RTX 3090 at full load at the same time. Now, as CPU thermals play such a big role when it comes to the boost clock of our Ryzen processor, we're going to go with the best cooling solution that we can fit in this case, a 240mm AIO. There are a few that will fit in the Ncase. I'd recommend one with flexible tubing, such as this one here, the NZXT Kraken X53. This liquid cooler also has the latest generation Acertec pump, which can spin all the way down to 800 RPM at idle, meaning that pump noise will be very nice and low. When it comes to the motherboard, a B550 ITX board will be absolutely fine here, but seeing as we're kind of going all out with this build at this point, I've gone with the X570i Strix from ASUS. The VRM here is plenty enough to handle our Ryzen 3950X even when overclocked, and it also helps that it's actively cooled. You also get a completely stacked rear I/O, which is one of the main benefits of going with an X570i board as opposed to a B550i board. Two of the less critical parts here, RAM and storage. These are mostly going to come down to personal preference and how much you need. The sweet spot for a build like this would be a 32GB kit clocked at 3200 MHz to 3600 MHz with relatively tight timings. But you do also have the option to upgrade to 64 GB if that's something that you think you'll need. Then for storage, again, completely up to you and how much you think you'll need. I'd recommend at least a 1TB M.2 NVMe drive to start with. And last but certainly not least, the Ncase M1 V6, a case that certainly needs no introduction on this channel, as I'd easily consider this to be one of the greatest PC cases of all time. excellent cooling support, and mind-blowing hardware compatibility given the sub 13-liter volume. So the build process went fairly smoothly. It always does in the Ncase M1, but the biggest hurdle that I encountered was definitely installing the GPU. This card is a big one, and it really is on the edge of what you can fit into this case. To install it, I actually needed to remove the top left beam from the Ncase's frame so that I could squeeze it in there, and this was mostly because I had to work around the fairly tall M.2 slot on our motherboard. So if your board uses a much shallower M.2 slot, you shouldn't have as much of an issue as I did, but still definitely take care. This is a big card for this case. And on that note, you will need to also manage the GPU's PCIe cables like shown. This is fairly easy to do with the pre-sleeved cables that come with the Corsair SF750. Just make sure that they're not overlapping each other, and this shouldn't take more than a few minutes. Even so, they will extend around 1mm from the width of the case, but I didn't find this to result in any panel bulging or difficulty in getting the panel on. But low profile 90-degree adapters would be ideal here if you can get your hand on some online. GPU sag is also something that you need to consider here, and to help with this I just used some of the packaging foam that came with the M1, which is fairly dense, and I just packed that underneath the front of the graphics card. It doesn't eliminate it completely, but it does help a ton. So let's move on to the thermal and noise performance to see what we're working with. For the 16-core Ryzen 3950X, this has absolutely no problem staying within a reasonable temperature, especially when paired with a 240mm AIO and a well-ventilated case. Boost clocks were also very respectable here across all 16 cores, and that's one of the primary benefits of running cooler temperatures. This was also with the radiator fan speed of just 1200 RPM, so a very quiet configuration. We'll take a look at that in just a minute. Thermals for the GPU were actually really solid as well, sitting below 70 degrees C with everything set to stock. That's extremely impressive given the form factor and also given the noise levels. By undervolting the GPU, we don't get much of a decrease in thermals, power, or noise levels, but it is something, and if you did want to optimize this system as much as possible, this is definitely towards the top of the list of things to do. I will also note that yes, I did try and fit a couple of slim 120mm fans underneath the graphics card, and although they do fit in there dimension-wise, it's impossible to physically install the card with them there. Also, looking at the thermals and noise levels, I don't think you actually need them there with this configuration. It's completely fine without them. And a quick mention on deshrouding, which is a very popular and extremely effective mod in the Ncase M1, which we've seen before. You can kind of do it with the ASUS TUF, but you'll need to remove the metal brackets that extend from the heatsink. So if you were to do it, you could fit a pair of full-size 120mm fans directly underneath the heatsink, but it would be a somewhat irreversible and permanent mod, and that's not something that I'm going to do with this reviewer sample that I have on hand. So overall, I think this is an exceptional little system, and one that totally makes sense to build if you are doing serious work around 3D rendering. And peace of mind and reliability is also very important for a workstation system, but I'll be honest, not something that always goes hand in hand with an RTX machine. But here, you can literally just slap all of these parts together in this case run them at stock, and you've got an extremely powerful, quiet, and reliable system. Also, you could just totally use this as a template as well if you instead wanted to go for an RTX 3080 and maybe a lower core count CPU for a more gaming focused build. That would work just as well. I guess one of the biggest points that most of you will be interested to see here in this video is the ASUS TUF RTX 3080 and 3090 actually fitting in the Ncase M1, and they do make a great pair as well. So all of the parts will be listed down below in the description if you are interested. As always, a huge thanks for watching, and I'll see you all in the next one.